Hi, this is Mrs. Juliana again. We're doing 17.2, and today our topic is similar figures. So, similar figures means if I have a shape that's a triangle, and then I have another triangle that is the same shape but a different size, then those two are what we call similar. Now, it doesn't just happen with triangles, though we probably will concentrate mostly on triangles, especially when we're doing proofs. Oh no, proofs. Anyway, it can happen with triangles, squares, any type of shape. If I have a pentagon, it can happen also with a pentagon. I didn't really grow that one much bigger, but whatever the case, these are similar because they're same shape but different size. Notice I have one small, one a little bit bigger. Same shape, different size. Even though this is not quite bigger, we're going to state it is. This is actually bigger than that one. Same shape though, pentagon, and different size. These triangles, same shape, different size. One's always a little bit bigger than the other, or one's smaller than the other, a little bit smaller than the other. And they still make similar triangles because they are different sizes but the same shape. So what we put in here, polygons, that just means many-sided figure with the same shape but different size. And once again, we'll be concentrating mostly on our triangles, but you might get a question here and there that deals with a rectangle or a four-sided figure or a pentagon or hexagon or something that's not just a triangle. So polygons are similar if corresponding angles are congruent. All right, or what we know that to mean is equal in measure. That's the angles, not the sides. So for instance, if I have, sorry, that wasn't good. If I have an angle that's a 90-degree angle, then I'm going to have the same 90-degree angle. And then 90 and 90 and 90, they're all going to be congruent in angles or equal in measure with the angles. So whatever this is going to be the same. Whatever this is going to be the same. And so on and so forth. I'm going to just hit, anyway, those angles are going to be the same. These angles will be the same measure as the corresponding angles in the other triangle. So as we know, angles are limited. They add to something. Like in a triangle, they add to 180. In a quadrilateral, they add to 360. They're somewhat limited in nature, but the side measures are not. I can have sides that are 3, 4, and 5, and then these sides can be 30, 40, and 50. They're not limited. They could be very, very large or very, very small, whereas the angles will stop at a certain measure because they'll have to add to 80. Dang, that's not good. Let's see if I can get back to where I was. All right. Next thing I wanted to talk to you about are the sides. So, or I was talking about the sides, wasn't I, before I lost my place. But corresponding sides then are what we call proportional. So proportional. That means if, for instance, my little triangles up there that are hard to read, if one side is 3, then it corresponds to a side that's 30. That has to equal the corresponding ratios of the corresponding sides. So 4 over 40. And that has to equal 5 over 50. So if you look at each one of those, 3 over 30 reduces to 1/10, 4 over 40 reduces to 1/10, and 5 over 50 reduces to 1/10. And you notice that all of the ratio of the sides are equal. 1/10 is equal to 1/10 is equal to 1/10. They're proportional, means if I take one side of one triangle and divide it or put it over the corresponding side of the other triangle, every single time it will be the exact same ratio. The ratio of the corresponding sides is called the scale factor. And that is very important. That's what we're going to be dealing with for the remainder of our lesson is the scale factor and the corresponding sides and the proportional aspects of that. If polygons are similar, oddly enough, so if I know this triangle and this triangle are similar, and I know 3, 4, 5, and 30, 40, 50, their perimeter here, 3 plus 5 plus 4 is 12. And then the perimeter here is going to be 90, 100, 120. All right, so their perimeters, if I take the ratio of perimeters, small to big, like I did up here, 12 to 120, again, I get 1/10, which is the same scale factor as the sides were. So when polygons are similar, so also are their perimeters. Okay, their perimeters are also proportional. And you note that in those two triangles, that the side ratio is 3 to 30 or 1 to 10. The perimeters are 12 to 120 or 1 to 10. All right, so what will be asked on our homework and what we need to know for future math classes is that what is the scale factor? And when we are given a specific order, we have to make sure that we state our scale factor in that specific order. So when it says triangle ABC to DEF, okay, if I go from here to here, ABC to DEF, then I'm going to get one scale factor. And then the second question is triangle DEF to triangle ABC. That means I go from here to here. So I have to make sure that as I'm doing these scale factors and quoting them, I make sure that if given a specific order, I have to do that specific order. I have to give them in that specific order. So when it says, what is the scale factor from triangle ABC to DEF, then I'm going to make this my first triangle and this my second triangle when I'm stating the scale factor. So with my first triangle, I have to come up with a side. So what side do I want? And if I use the smallest side, that's a good way to check. Small side to small side, always have to create the ratio that way, small to small. So if I choose 8, then on my next one, on my next triangle, I have to make sure that I pick the smallest. So is 12, 15, or 21 the smallest? Well, 12 is the smallest. So those are my two corresponding sides I'm going to pick. Because it says triangle ABC to DEF, I'm going to pick my 8 side, that's the smallest side, and put it over my 12 side, that's the smallest side. So 8 over 12. So now I have to simplify it if I can, which I can in this case. I can divide out of 4, and I get 2 and 3. So my scale factor from ABC to DEF is 2 to 3. All right, now if I go in the opposite direction, triangle DEF to ABC, then I have to say 12 first over 8. 12 over 8. And again, divide out of 4, and I get 3 halves. Or if I figure it out and I have it all simplified one way, then I can flip it for the other way. So 2/3 becomes 3 halves, depending on which of the triangles I've been asked to state my scale factor in first. So what is the ratio of the perimeters? And this is DEF to ABC. So here's DEF, and it's going to be 3 to 2, because it'll be the same as the scale factor for the sides. All right, similarity statements. First of all, we need to make sure we know the symbol. Oh, it's right here. So the symbol of similarity looks like that. It's just the tilde part of the congruent sign. You know, remember when triangles are congruent, when they're congruent, the angles are congruent. All the corresponding angles are congruent. In similar triangles, all the corresponding angles are congruent. So they share that in common, both congruent and similar triangles. The difference is with congruent triangles, all the sides are also the same, whereas when we're talking about similar triangles, then their sides are not congruent. Instead, they're proportional. So still, though, there's a similarity statement that we use, and that similarity statement is important because it states whether or not triangles are, or which angles are still congruent, just like when we deal with congruent angles. Similar triangles line up by congruent angles also. All right? So when we deal with if I have one angle here congruent and one angle here congruent, just like in congruent triangles, I would say triangle, I would start with this side, then this, or this angle, then this angle, then this angle is congruent to this angle, triangle, this angle to this angle to this angle. So they're lined up just like in congruent triangles, but this is asking for a similarity statement for these triangles above. So if you notice, you have a 1 arc, 2 arc, and 3 arcs on the triangles, and then 1 arc, 2 arcs and 3 arcs on the bottom triangle, on triangle D. Yeah? So when you state your similarity statement, you would say triangle ABC. So notice that we went in order from 1 to 2 to 3 arcs. Then we would say similar with our little similarity tilde there, just the tilde, not the congruent part underneath. Triangle 1 arc is D, 2 arcs is E, and 3 arcs is F. So that A and D line up together, B and E line up together, and C and F line up together because those are the corresponding and therefore congruent angles in the similar triangles. So that's how we do similarity statements. If you're looking at example 1, list all congruent angles and write a proportion that relates to the corresponding sides. So we have triangle JKL similar to triangle PMN. Now, on angles, just like we did with the congruent angles and the congruent stuff, triangles that we were working on in the previous chapter, J and P are congruent because they line up in the similarity statement. So you could say angle J is congruent to angle P because they are both the first angle listed in the similarity statement. And likewise with the second, angle K is congruent to angle M, and with the third, angle L is congruent to angle N. So those are the 3 angles set up as they are congruent. Now, the sides are a little tricky. I like to mark these because sometimes they're not lined up correctly. And if you notice, JK are the first 2 in the first statement, and PM are the first 2 angles in the second triangle. So those line up together. Now I'm going to mark the next set. KL is right here, right? And MN is the one that it lines up with. So you have to be careful with that. And then lastly, we have JL, and according to our statement, JL lines up with PN. All right? So once you color code those, I like to color code them. Of course, we can't say they're congruent because they're not. They're similar but not congruent, but they are the corresponding sides. And we have to just list them one at a time here. JK over PM as a ratio is equal to KL. And I'm looking at KL and then MN in my statement over there to make sure that I, again, state them in the correct order. And then JL is corresponding to PN. All right, so that's the ratio as they go. Okay, and that's one thing that we do. The other thing that we do is, again, we find sides and we have to set everything up appropriately and make sure that we have corresponding sides. So AG and KX are corresponding, and GM, and XD are corresponding, just so you know. So it's good to just set that up first so you know what's going on. So then we would take 32 over x plus 3 is equal to 36 over x plus 6. Now notice 2 things here. First of all, I started with this triangle both times, so 32 over x plus 3 equals 36 over x plus 6. So 1, then this is the second one, it's always on the bottom. And then I set up the correct ratios to make sure that I have my sides that are corresponding matched up correctly. And 1 from one triangle over the corresponding side from the other is equal to 1 over the corresponding side of the other. All right, I'm just going to write this out really fast because I'm running out of time. So I need to stop the video here in about 30 seconds. But you would cross multiply then. 32 times x plus 6 equals 36 times x plus 3. I'm going to stop the video, and then we are going to continue with the next video. So let's see how that goes. If I can find the stop. Here we go.